think we're going to go ahead and get started. You guys hear me all right, right? Perfect. Well, good morning, and welcome to the session with a very, very long title. It's so long that it actually doesn't fit the screen there. We're going to talk about connectivity to software as a service cloud, Office 365 to be precise. And before I start, I wanted to get a basic feel for the audience. How many of you consider yourself as purely application level people with no knowledge of networking whatsoever? Okay, looks like we got some pretty focused audience. Who considers themselves having some networking background? Okay. Who considers themselves purely a networking expert with no awareness or desire to be at layer 7? Okay, very good. All right, I'm not a fan of large agenda slides, so in lieu of introduction, this session is focused on connectivity to Office 365 for enterprises. We're going to be discussing some fairly complex scenarios. I'll try to articulate some of their lessons learned, trends, pitfalls, best practices. We're going to be focusing more on strategies, not features. So I'll try to give you some perspective on what we've seen works in Office 365 enterprise connectivity space. But what is probably more important, the trends that we see, the investments that we encourage our customers to make to keep their connectivity strategies to Office 365 or to SaaS in general future-proof. We designed this session with one very, very particular goal, which is to make your Office 365 end user experience better. So that's going to be the main pivot in our conversation today, as well as the main pivot in our Office 365 connectivity strategy that we are becoming very vocal about. And as we go through this session, we'll try to dispel some myths. There are a lot of assumptions. Some of them are incorrect that people have about what Office 365 is in the way it projects to networking and connectivity. And this is one of the few sessions, if not the only one, that has a diagram, a slide, or a picture in every page. So if you are sitting in the back row, I encourage you to move up a little bit because some of those imagery could be fairly small if you care about the details. We linked to a couple of other relevant sessions for follow-up. These represent the subjects in or around networking connectivity. But again, this is a strategy session, so we're going to focus on some fairly broad strokes. So what prompted us to create talks similar to this is a very interesting realization that Office 365 is one big cloud available to all customers out there. Yet, customers continuously report different experience with Office 365. And what we see is that connectivity is one of the leading causes to these experiences differences. Customers report differences in performance, difference in availability of Office 365. We often see that networking is being a blocker for fast onboarding to Office 365. We also observed a couple of trends where a single network failure on the customer network or on the provider network renders Office 365 inaccessible to many, many users, including maybe 100% of users in some selected situations for a given company. So these trends are fairly disturbing, and we wanted to make sure that the choices that you make for connectivity architecture to Office 365, to software as a service cloud in general, and this goes beyond Microsoft, all software as a service clouds, these decisions can have one of the most profound impact on the user experience. And we want to make sure that you're aware of some of their trends, best practices, investment areas, as well as make these decisions in alignment with how we evolve Office 365 and Microsoft 365 software as a service components. So let's set some context. I slipped a couple of words here. I said Office 365 and software as a service cloud. If you step back a little bit, there are many types of clouds. And most people agree that there are three major categories. The infrastructure as a service. The classical example here is Azure Virtual Networks or Azure Virtual Machines. Platform as a service, like Azure SQL or Azure Blob Storage, and software as a service. The prime example here is Office 365. When you look at all these connectivity options and all these cloud options, the type of the connectivity that the customers invest in order to establish connection to these type of clouds differ depending on the nature of the cloud that the users are connecting to. So we try to look at what drives these major differences in networking philosophies. So I'll try to compare and contrast how infrastructure as a service, such as Azure Virtual Network, differs from software as a service, such as Office 365. So one of the key differences that we see over and over again is that infrastructure as a service is predominantly focused on IT professionals, right? It is designed for IT pro to build their own solutions. The software as a service is a prepackaged application that is predominantly focused on end-user experience. And that philosophy drives some major differences in the way that the customers optimize their network connectivity to those. In the IaaS world, the cloud is very, very focused on the infrastructure. The entire idea of the tenant in the IaaS world is focused on infrastructure and network level up. In the software as a service world, and with Office 365 in particular, the concept of the tenant is purely at the application level. And again, that drives some major differences in the way that the customer should think about networking to software as a service cloud. If you worked with Azure virtual machines and virtual networks, the first question that you are asked to answer is, what is the location? What is the region that I want to put my IaaS instance in? In the software as a service cloud, the location is always global. You have influence where your data is physically stored, but the user experience with the software as a service cloud is truly global. The focus in the software as a service cloud is scale out, with a scale as big as the entire planet. When you look at the different financial models, the infrastructure as a service gravitates to consumption-based, per gigabyte, per instance, per location. In the software as a service world, it's all about the user. Now, when people connect to Office 365 compared to Azure Virtual Network, the SaaS part of the equation looks like an external network to your existing on-premises environment. In the IaaS world, the IaaS instance is considered an extension of your internal network. And that drives some fundamental differences in the way you think about the best connectivity type to these. For Azure Virtual Networking, it is optimized for private-like connectivity. It is location-specific, a logical extension of your on-premises environment. In the software as a service world, again, Office 365 is an example, but this goes much beyond just Office 365. The connectivity is best provisioned over the internet. It's public connectivity, global scale-out. And all of these differences, they also drive different philosophies in the way people should think about networking. In the IaaS world, if you're designing a solution for the infrastructure as a service, you extend your existing on-premises environment to the cloud. For software as a service, it requires a new approach to networking. And the same applies for security as well. So it's the right part of this diagram that we're going to be talking about for the remainder of this session. So I encourage you to enter the mindset of software as a service, Office 365, Microsoft 365, and user experience focus type of discussions. So I mentioned in the beginning that we're focused on enterprise connectivity. But what really makes enterprise networking strategies to the cloud different from, let's say, consumers? If you look back, the consumer experience with the internet has been fairly evolved in the last decade or so. The consumer experience was dominated by using Netflix and YouTube. You provision your ISP connectivity, you put a fairly simple wireless modem or another simple device. And when Office 365 comes into the consumer world, it's actually a fairly insignificant event. All the connectivity is wide open. Your internet bandwidth is provisioned for real-time video. A couple of additional mailboxes or a SharePoint experience on top of that is not going to be, particularly challenging for consumers. However, if you put yourself in the enterprise shoes, for decades, enterprises have been evolving their networks to protect themselves from the internet. They have been putting some fairly state-of-the-art security stacks. So this diagram throws a lot of acronyms at you. all those are components of security that many enterprises choose to deploy to protect their users from the internet. While the volumes of these transactions, the criticality of that experience was largely limited to recreational internet browsing. So when Office 365 comes in, the mission-critical, high-volume, high-performance demanding application, it eclipses the enterprise original internet projections. So that drives a lot of friction, especially on the architecture which was not created to be simple. It was created to protect the users from the big, wild internet, not to provide excellent connectivity for high-volume, mission-critical applications. And we see this in pretty much every enterprise deployment, that the simplicity of the networking connectivity is one of their biggest goals, but it's also one of the biggest challenges for the enterprises to accomplish. Now, let's look at the topological view of the enterprise. Office 365 is a distributed application, but in the enterprise landscape, there is a concept of the last mile. This is something that the user needs to travel typically from their location, from the branch office to a data center where his requests are being scanned before they're allowed in through the internet. And that last mile could be fairly long. We have customers who backhaul requests across very large distances, sometimes across continents, in order to have their requests scanned by the security stack in the remote data center. And that generates a very interesting dilemma. When the user is inside the enterprise boundary and they reach to the external destination, such as Office 365, their experience may be hindered by this last mile and heavy processing at their perimeter. While if the same user goes home and accesses Office 365 from the same city, from the same metro, the experience is so much better. On this diagram, that's the person in the blue circle, right? Many enterprises make the last mile even worse by forcing the users to VPN in. This architecture has one important pivot. It is not direct. For the internet destinations, it was very justified, right? But for Office 365, that may have a fairly profound impact on the user experience. So that's why we started talking about enterprises, right? These challenges are real, and we're going to try to give you some hints on how to solve them at the strategic level. So what's our motivation? It's not just to make Office 365 experience for your users tactically better, but also to make sure that the changes that the cloud brings to your enterprise networking landscape, the changes that impact how data is accessed, how the connectivity is designed, these changes for you are future-proof. We want to make sure that the investments that you make, the decisions that you make to make your networking and connectivity strategies better accrue to Office 365 experience today and remain future-proof in the next foreseeable future, right? We want to turn the network that you have and that you've been invested in from a bottleneck, which unfortunately our track record suggests that it often is. We want to turn it into an enabler and differentiator for your company to provide delightful user experiences for the trusted cloud like Office 365. Now, let's take a look at some of the broad trends. It's always good to align ourselves to something that is happening. We're seeing that some of these trends are accelerating. And you will find the reflection of these trends in anything that we do around Office 365 connectivity engineering-wise. So I'm going to try to compare and contrast the before and after state. The first trend is that software as a service disrupts traditional connectivity. In the past, connectivity was heavily focused on on-premises, MPLS-based, everything is contained in the bubble type of model. With the software as a service cloud, the users are everywhere, and the cloud is also distributed. So that drives some fairly profound changes to how the traditional connectivity model needs to evolve. The second important trend is that security, the controls that people got accustomed to on premises and were focused on applying those security controls purely at the network level, these controls are moving into the application. The third is that internet, maybe 10 or 15 years ago, was this big scary thing where reliability, performance were on the top of the concern list. And indeed, if you used internet back then, in order to reach any internet destination, you have to cross a variety of ISPs. Everybody was trying to play hot potato routing. Nobody was responsible. The destination was topologically far away, and that drove some unreliability trends. The modern internet, especially when you put it in the context of the large software as a service cloud, such as Microsoft's, is actually fairly short in distance. For most enterprise deployments, we see that the right choice of the ISP keeps the packet going to Office 365 on the ISP wire within the metro area. And then it gets handed to the cloud network, to the Microsoft global network in the same geographical region. So internet is becoming more reliable when we talk about specifically internet connectivity to the software as a service cloud like Office 365. We're also seeing a trend where network solutions become more application smart. And this is a very powerful concept because these network solutions can differentiate different applications and apply different logic. You apply different logic to YouTube versus Office 365 depending on your business priorities. So application awareness of the network layer is very important. And finally, there is a very pronounced trend that applications are moving to the cloud. Well, connectivity is also moving to the cloud. And I want to acknowledge that because that movement could be very empowering, but it also could be fairly impactful if you don't factor it in under the right angle. So enough with broad strokes. Let's start digging into some of the deeper concepts that are very important for Office 365 user experience. And one of the key concepts here is latency. We call latency as the main currency in the world of cloud performance. It is not the only currency. Some people want to talk about jitter, packet loss, other network characteristics. But the thing with latency is once you spent it, it's very difficult to get it back, right? And our data suggests that the latency has the most profound impact on the user experience. We will have a couple of demos later that will show you how latent links and backhauling effect can cause fairly drastic impact on users. If you look at the overall latency envelope, in this topology diagram, we distinctively focus on several key components. The first mile is happening within the Microsoft cloud. The middle mile, think about this as your ISP. And then the last mile is all the customer infrastructure from the end user location before their packet is allowed to egress to the public network, to the internet, to your ISP ecosystem. And the end-to-end latency is the sum of all these components. When enterprises make choices about connectivity, when they develop philosophies in extending their connectivity strategies to software as a service cloud, the choices affect the latency envelope pretty drastically. Number one is the backhauling distance. Some enterprises, they still backhaul Office 365 requests across large distances, and the physics kicks in. You cannot beat the speed of light. Distance translates into latency. The intermediate processing overhead on some of the legacy security stacks is also known latency generator. And then finally, the choice of the ISP. The ISPs that have great peering relationship with the Microsoft global network, we're going to highlight that a little bit later, they tend to have a much smaller latency envelope for the same location, for the same geo, compared to the ISPs that do not have a developed peering relationship with a destination network yet. So those are factors that could all add up and increase the latency beyond the tolerable level. So let's try to see what impact can the latency have on the end user experience. So in this example, we model this after a real customer, despite the name here says Contoso. That customer is 80,000 enterprise seats. They are a worldwide customer with offices spread around the world. They had a fairly evolved MPLS network with some elements of WAN acceleration. And then their data centers with a security stack that connects them to the internet are located in the United States. Because they're a worldwide company, everything backhauls to the United States, where the security stack performs some state-of-the-art operation to protect the users from the internet. And this is where Office 365 traffic was gravitated by default. Now, we're going to take a point of view of the user in Australia. Not because we picked Australia for a reason, but because we want to show how the users in the branches, in their distributed branches feel. And the topology that resembles that demo is pictured here. So the user from the branch is going to be using their enterprise WAN and then egressing in the remote US location before they get to Office 365. So let's see how it looks from the end user experience perspective. We're going to touch on a couple of KPIs. What you're seeing here is Outlook experience. So first, we're going to try to measure the distance, the latency from that user to Office 365. And I'm using PS ping here so that I'm not relying on ICMP. I'm using HTTPS transactions. And the latency here is 215 milliseconds. That's pretty long, right? Typical from Australia to US, but pretty long. My next step is I'm going to try to exercise instant search. And I'm going to look what Outlook reports as the search latency. It's a little bit small font, but I'm going to highlight this for you. It's 300 to 450 milliseconds. And then the user goes and tries some Outlook operations involving delegate access, online archiving. You see how fast, in quotes, the UI renders. Every click results in maybe a second or so delay when the data needs to be downloaded from the server to render. And then the user goes into the calendar access, calendar delegation. It's a very popular scenario for admins and executives. And you will see what the user experience is there. User goes to an executive calendar, wants to review their meeting information. That starts in a couple of minutes. Clicks do not result in the immediate UI response. It needs to download the information from the server. Finally, the UI will appear. In a little while, the user says, yes, I want to see it. And eventually, see a donut, right? I cannot quantify that experience. I'm going to use a very scientific method. I'm going to call it dreadful. This is where the users typically bail out. They say Office 365 doesn't work for me, right? And that's what we're trying to avoid. Next, user is going to SharePoint and tries to download a presentation about software as a service networking. It's a 15 meg file. And as you can see, it's about 6 minutes to download. I'm not going to wait 6 minutes. I'm going to cancel out, kind of bail out of that experience. I'm going to record that it's about 300 seconds, so fairly long for a 15 meg file. And then for my Skype for Business experience, I'm going to use a tool called Skype for Business Network Assessment. It measures some critical call quality characteristics. It actually simulates a 17-second conference call and measures the call quality in terms of packet loss, latency, and jitter. And after 17 seconds, it shows me the statistics for that call, right? I'm running it from the real user workstation, and I'm going to record the numbers. They are above the threshold that Microsoft recommends for decent call quality. So for this particular office, the Skype for Business Network Assessment will fail, right? And it will require some remediation. All right, so let's do some comparisons. You may say, hey, the user is in Australia, right? In Australia, it's fairly difficult to get good internet connectivity and have reliable Office 365 experience under low latency. So what we did is we tried to pull some stats. In the last 30 days, we measured a representative set of end-user transactions, and we tried to extract what is the latency, what is the network distance that the user is located from the cloud. And this resulted in this histogram, right? For major metropolitan areas in Australia, there are 5 latency envelope buckets that we grouped it by. The green is less than 50 milliseconds. The black is more than 250 milliseconds, or 200 actually here, right? As you can see, the users from the same metro area, from the same geographical region, with the same Office 365 service are having a drastically different experience, right? So it is possible to get great Office 365 latency experience in Australia, but for some reason, some customers are not enjoying that. So we started double-clicking. We took a couple of customers, and we said, how does it look at the worldwide scale? So it's going to get scientific in a minute. We recorded a couple of billion of transactions. We measured their latency from the user desktop or mobile device into Office 365. And then we plotted this using the cumulative distribution function. What it means is that On the horizontal axis, there is a latency envelope from 0 to unreasonable, which is close to 500. This is where the users start bailing out. And then on the vertical axis is the percentage of users that fall at or below the given latency envelope. And what we saw is that different enterprises, they have a drastically different cumulative distribution function, which translates into drastically different experience. Like the customer number 4 in green, 90% of their users are within 20 milliseconds from Office 365 for a worldwide distributed customer. For another worldwide distributed customer, the red customer, customer number 3, only 20% of the users are enjoying latency envelope better than 400 milliseconds. 80% of the enterprise is seeing the UI that I just showed you in the previous demo. 2 different customers, worldwide distributed, drastically different latency envelope and user experience. So the remainder of this talk will focus on how can you get to green, right? To do that, let's understand what the cloud architecture is in terms of networking connectivity, and then project it to some of the actions that you can take. So number 1, Microsoft Global Network. That is the first enabler in this architecture. And the main pivot there is the number of peering locations, or the concept of the peering location, where Microsoft Global Network has presence. The second very important concept that we're going to be discussing is the concept of the distributed service front door. And I'm going to double click on that later, but right now you can think about this as a front-end system that the users are connecting to. And then finally, the third tier is the data at rest. This is where Office 365 stores your data in Microsoft data centers. And all these 3 things, the global network, the distributed front door infrastructure, and the intelligent content placement close to the user, is what represents this major trend that you want to align to. By definition, the ordinarity of data centers where Microsoft stores data is fairly low comparatively, right? Right now, I think we have active or announced about 45 data centers where Office 365 stores your data, right? If you look at the number of service front door locations, that's over 100. So the concept of the service front door allows further reach towards the end user. And then the concept of the network peering location is in it having larger ordinarity, right? It's in more than 190 peering locations with 27 ISPs being peered directly with a Microsoft network over the internet. Now, the most powerful thing about this architecture is that it's always evolving. And it's evolving towards the user. We're making huge investments in expanding the reach of Microsoft Network, attempting to come closer to the user. The front door locations are also being expanded, so that's where the latency envelope between the user and Office 365 is important. Users connect to the front doors. And then finally, we also expand the data center mesh where we store customer data for Office 365. So the cloud is trying to become closer and closer to end users. That is the most fundamental concept that we encourage all customers to embrace. Unblock that motion when the cloud wants to come closer to your user, to the extent that in the fullness of time, most users could be enjoying 10 milliseconds from their Office to Office 365. Very important concept. Now, double-clicking on the Microsoft Global Network, this is a fairly known slide. In fact, I think they're displaying just the same slide on the Azure networking session. Microsoft Network is big. We are continuously investing into it. Take full advantage of it, right? No matter where your destination is, if you enter Microsoft Network in one region, we will backhaul these requests into another region. We will take responsibility for the availability, performance, and other characteristics once the request enters our network. Fast forwarding to the next concept, Office 365 front doors. Service front doors, they have many different names. And people who like to be very detail-oriented may have heard the concept of edge node. In fact, I think they just announced it in Azure sessions. Now you can take advantage of edge nodes for your own applications. Some of the front doors in Office 365 are using relay server type of infrastructure. That's particularly important for voice and video for Skype for Business and Teams. Some people call it client access front ends, especially the people who deal with Exchange. Some people like to refer to service front doors as content distribution nodes. I mean, all these different names, they represent one core concept. It's the service front door that the users connect to. The user never connect directly to the data, to the disk. The user always connects to the service front door, which effectively is an endpoint. So it's the connection to the front door that matters, not to the data center where your data is stored, right? The front door is the experience rendering point. The closer is the front door, the better is the user experience. Now, many technical professionals are asking us, hey, what mechanisms does Microsoft use to architect their front doors? What load balancing technologies are they using? And the simple answer is, it varies, and it will change over time. If you want to have some preview on what different tech we use, it ranges from GeoDNS to Anycast DNS to Anycast TCP to Anycast UDP to application-level discovery. So it's a fairly evolved and diverse concept. The key point is you don't have to worry about the implementation. There are some very specific guiding principles that we encourage our customers to do to ensure that their network is future-proof from all the implementation changes that are in the innovation pipeline. So the key point here is direct your users to the closest front door geographically and topologically as possible, right? And then remember, the front door will attempt to chase the user. Now, let's look at Office 365 endpoints. Endpoints is a very important concept, also known as URLs and IP addresses. Many customers, they need the endpoint information so that they can, number one, whitelist Office 365 destinations. If you're operating a closed network, you kind of need to permit the destinations that your users are allowed to connect to. Some customers, they like to customize and optimize their networks. In this case, endpoint information is critical. Many customers, they want to differentiate Office 365 experiences from some of the lower priority, non-business focused network experiences. And again, you need endpoint information to do that. And then finally, many solution providers and our networking partners, they would like to automate Office 365 network configurations, and they also need endpoint information. So in the last couple of years, I would say we erred out on the precision side, and we tried to document in finest level of details every single Office 365 endpoint that the user can ever connect to. And we published it in this location. How many of you have visited that location at least once? Office 365 URLs and IP addresses, about 60–70% of people. And the common feedback that we received about that is it's long, and it changes, and it's very difficult to reason on. And my security person will catch their head on fire if I ever show this list to him with the ask of whitelist. Those are very valuable feedback points. And we're happy to report that we took some action on them. So number one is in the last 2 years, we drove a continuous effort to shrink the overall number of entries on that list. From thousands of entries, right now we are at the hundreds of entries, so about a factor improvement. Now we have some further aggressive plans to shrink it even further, but that's not the key point that we wanted to discuss today. The key point there is we recently announced a new taxonomy that allows people to prioritize. Not all endpoints are created equal. Some of them, they have profound impact on the user experience. The users connect to them every day. And if something happens to the traffic to those endpoints, the users will call you, and you will call us. Some of the other endpoints are less critical. For example, the endpoint that Outlook uses to render weather information if the user decides to schedule a meeting in the remote city. Yes, it is still a part of Office 365 experience, but it's not the most critical endpoint for you and your network team and your security team to focus their attention on. So the new priority-driven taxonomy, there is a link here. Please revisit that page and make sure that you can take full advantage of that. Now, with this taxonomy, the optimized set, this is the vital few Office 365 flows if I were to quantify it, it's Exchange Core experience, SharePoint experience, and Skype for Business and Teams media. Very few number of URLs. Much fewer number of IP addresses. Much easier for the security people and network people to reason on. And that bucket accounts for 75, in some cases 95% of your networking volume to Office 365 in terms of bandwidth, connection count, transactions per second. So that becomes a focal point, right? And then we also, in this new taxonomy, we attach some fairly clear guidance allowing customers to do incremental changes. So if you're on day one of your Office 365 experience optimization and you want to invest in your network and you have a fixed budget, this taxonomy allows you to focus, start with the optimized set. It's highly critical for the user experience. It has the most high volume. It's also tends to be the most trustworthy and well-known in the networking and security industry, right? So that becomes the first step with just a few actions, very few number of URLs, and a fairly manageable number of IP subnets. You can unlock the full potential of Office 365 user experience. We're going to have a demo focusing on that. And then the rest of the categories, the allow set, it is still required, but you don't have to invest network energy to do all the heavy lifting on day one. And then the default set, it has a lot of external destinations, third-party content distribution networks. I think the default list still has Facebook and Google in it because some Office 365 experiences, they direct the users to these services for the purpose of migration or interoperability. So we still want to be complete in our definitions, but this new taxonomy gives you an ability to focus and invest your network and security energy in the stuff that is the most important to get right. And what we also did is we packaged this away from this plain HTML page, which was great for night reading if you want to fall asleep. And we packaged this in the REST API, a web service that the customers and partners can use to automate their solutions. Now, the nice thing about the optimized category here is that the rate of change there is drastically smaller. It's expected to be more seldom than once a year. So if you focus on the optimized set, it's a stable ground, it's the high volume, high business impact, and the high network and security ROI to get right. All right, so the key point, focus on optimize. That's why we call it optimize. That unlocks the user experience the most. All right, so let's talk about trust. Let's do a social experiment here. You guys have your cell phones with you, right? I want to take your phones, unlock it. All right? A few people did that. And then pass it to the neighbor on the right for the remainder of the session. Well, it made you think. So you don't necessarily trust putting your device to the hands of third party. But if that third party was an accredited entity, if this is the person that you know, if this is the person that you trust, like your family member, if that person was tasked to actually fix your device and you're watching while he's doing so, I bet you will be a little bit more comfortable than just giving your phone to a complete stranger and walking away. Now, let's project it to the concept of the network trust. The basic axiom here is this is one of the key decisions that you need to make for your Office 365 deployment. That's one of the key arguments and discussion points that needs to be had with your networking and security people. The truth of the matter is services that have higher network trust as their destination, they're simpler to connect to, and they exhibit generally better user experience compared to some unknown internet-based website. There is actually a strong mathematical equation that I'll try to plot here in the non-scientific manner. And it's an inverse function. On the horizontal axis, this is the level of trust. On the vertical axis, there is a level of overhead that you have to spend in order to compensate for the lack of that trust. Think about this, a security stack, man in the middle, that needs to scrutinize the user transactions with a given destination. If you trust something very little, such as the generic internet website, that you don't want your users to connect there unbrokered on the first place, then the level of low trust drives high compensating overhead. You have to spend a lot of energy to scrutinize every request to make sure that it's safe. If you have a line of business application that you created, right, or you sanctioned, it's verifiably trustworthy. Your business made a decision to actually use it. The level of overhead that you need to have objectively to connect your users to that application is lower. It's never zero, but it's lower. Now, if you plot some technology labels here, the higher the level of trust, the more lightweight network and security controls can be. If you put the point of view to the left, you start engaging some of the heavy lifting technologies all the way into content gateways, decryption of data in flight, scrubbing, et cetera, et cetera. So there is a very important decision for you to make is where on this spectrum do you place Office 365? Most customers, they place it somewhere in the middle. The business bought Office 365. It's one of the major applications. But we also are doing a lot of work to give you reasons and means to shift the point of view more and more to the right. So in this callout with a font size 4 that you cannot read is the sample list of security features, compliance features, privacy features, isolation features that you can use to shift the trust level to Office 365 more and more to the right. Now, it will never be infinite, but the key is to get away from the red and maybe the yellow zone, right? Place it comfortable in the green zone. And in the context of the previous discussion, you don't have to do it for all Office 365 all up. You can focus on the optimized set, on these vital few applications, Skype for Business and Teams Media, Exchange core services, and SharePoint core services. If you work with your network and security team to rationalize the placement of the optimized set on this diagram, that is going to drive the most profound impact on your user experience for the years to come. So the key point is whatever that trust level that you reasoned on for these key Office 365 services, differentiate based on that trust level, based on that category as early in the network topology as possible, as closer to the user as possible. So let's take a look at how this can play out in the real topology. The starting point is going to be an enterprise that sends everything to the default security stack that applies exactly the same action on everything that it sees. And it doesn't really care where the destination is. It could be a raw internet website that serves you raw code and tries to infect your users with viruses. It could be a social network that your business does not necessarily allow to be used while the user is at work. It could be another cloud, or it could be Office 365. That security stack in this default set is trying to apply the same very action, the highest bar. Now, security stacks, they require a lot of energy, a lot of processing power as the volumes grow. And when this happens, the industry tends to gravitate those security stacks to central location. That drives the scale up. Or maybe gravitate those security stacks to other clouds, which means that the path to Office 365 may become longer. Now, let's imagine that the previous concept of network trust is reasoned on by some network device very close to the user. We're going to give you a sneak preview on how it looks, but let's just assume that that network device can tell Office 365 key experiences from that unknown internet website that has bad reputation. In this case, that network device can say, I will permit, based on your decision, to connect my users directly to Office 365, just to these services. The rest will go to that security stack. There is a certain amount of power in that decision because that makes the cloud work for you. What happens next is that application differentiation done by the device enables the cloud to move closer and closer to you. And in the fullness of time, if that device uses their internet as the public network, then the cloud, through peering strategy, through front door placement, will attempt to get closer and closer to your users. So that decision about the network trust, that decision about the differentiation of key Office 365 flows as closer to the user, it makes the cloud evolution work and accrue value to your users, even if you don't do anything else. Very important point. All right, so let's go to the next slide and discuss their hub effect. Hubs have been used for generations in networking topology, and hub and spoke model could be quite useful, but it forces you to backhaul the traffic to some centralized location. Usually you want to do that in order for that traffic to be either served there or processed. In the classical world, hub and spoke topology may be influenced by security stacks or some of the applications that are heavily centralized. Usually hub and spoke drives the scale-up mentality, as well as the challenges and bottlenecks that are associated with a scale-up. Remember, when we talk about distributed SaaS experiences, it is always scale out as the first principle. Generally, hub and spoke works nice when you actually connect your users to the services that are hosted in that hub. But what do you do if you want to connect your users to the distributed cloud, to all these distributed front doors and peering points that we discussed previously? Now, remember, hub effect can be induced not only by your data center topologies, but it could also be induced by the choice of the ISP. If they have peering relationship with Microsoft only in one location, all the traffic will go through that peering location as a hub. Or a choice of network interception techniques, such as proxy settings or tunnels. They can also cause the hub effect. If you aren't careful, then the hub effect for the distributed Office 365 will look like that. Lots of users in branch offices around the world, few on-premises data centers where the traffic is being hairpinned on. The diagram on the right part of the slide is a small fraction of Office 365. You notice that as we talk, Office 365 is getting bigger and bigger, and it no longer fits the slide. So what you see there is just a small piece of Office 365, still distributed. But the hub effect hairpins that traffic, increasing latency from that user. Now, there is a modern theme to move your data center into another cloud. Does it cause the hub effect as well? Well, it may. I think the most important here is count the nodes. If you look at cloud solutions, they are typically present in multiple locations. Even if you deploy in Azure IaaS or in Amazon Web Services, or you're using some secure web gateway in the cloud application, they're usually present in multiple locations. But the key question is, do the math and count the ordinarity of their locations that you want to connect to, aka branches, with a number of peering locations and front door locations that Microsoft has the service in. So for a typical customer, 100 branch locations is fairly typical. Microsoft has more than 100 locations where Microsoft Global Network has a peering in. That's 100 by 100, it's 10,000. Different combinations. Now, if you hairpin the user experience in that distributed graph through a given location, the key question that you need to ask is, how many of these locations that the traffic is being hairpinned on? And you should count used, not available locations. Because in many cloud-based solutions, the cost models will drive you to fewer and fewer locations. It is more expensive to have your stuff in more locations, let's say in the IaaS world. So very, very important to do the math in order to avoid the unintentional hub impact. And the relationship between n to 1 to m, where both n and m are large, is unacceptable. The relationship n to few to m is hardly acceptable either. You really need to strive for something that resembles the full mesh. Now, very important data point. Many solutions, they pride themselves to being closer to Microsoft. They highlight the yellow line. They say I'm 2 milliseconds, 5 milliseconds from the nearest Microsoft location. And that's great. But when you look at the end user experience, it's not the yellow line that matters. It's how close are they to your users. Every one of them. And the users are distributed. So it's the combination of the red line and yellow line that determines the end user experience. Don't let this slip your mind. And always compare it to local and direct. That's the physics-driven model. That's what your competitors will likely be able to do. And the direct and local line is always shorter than any type of detour unless the hub node count is very, very similar to the ordinality that we placed here, which is order of hundreds. Now, for the fairness of it, nothing beats the full mesh. So if we fast forward a couple of years, then the full mesh model with the direct and local egress will offer the best Office 365 experience possible. So the key points here, the key elements to make your networking strategy of. Number one is evolve hub and spoke model for Office 365 experiences. Now, you don't have to touch the big wild internet. You can just focus on the optimized set, those vital few Office 365 flows that we previously defined very, very narrowly. Focus on those and make them not hub and spoke. And number two is if you must do hub and spoke topologies, then count the number of nodes, right? And evaluate the node count for the scale of your enterprise. See if the equation is favorable to your user experience. Now let's try to model some of these exercises and try to put some of the things that we've learned on this session together. So here is the representative enterprise topology with multiple branch offices. Let's assume 100, but the slide only fits a few. We used continental United States as an example, but it can certainly be projected to the worldwide scale. And the cloud, Office 365, which is present in every major city as far as the peering locations and the front door infrastructure is concerned. So the starting point for this enterprise is backhaul everything to the data center, right? And then the data center uses their ISP local to that data center, and then in that location it enters Microsoft network, served by their service front door, which fetches the data. The end-to-end latency envelope in this topology from the user to the front door is about 65 milliseconds. Now, you project it to the worldwide scale, and that architecture will be fairly close to 200, 250 that we observed, or even worse. So let's make a note of that, 65 milliseconds for this default case. Now let's imagine that the user in the San Francisco, California office says, hey, I have great internet connection locally. How can I put this to use for just Office 365 flows? I don't have to sacrifice security and route the internet there unfiltered, right? Just these key Office 365 experiences. Let's say Skype for Business, voice and media, right? Or Exchange core services. There is an ISP that has local peering relationship with Microsoft network in that very location. So the choice of the ISP is very important. And then if that local egress is permitted for just Office 365 optimized set, then the request will flow locally and will hit a closer front door. So that's about 25 milliseconds, assuming that the front door is in Seattle, Washington. So you can see the latency savings immediately just by that decision. But that's not it. The cloud continuously monitors where the requests are coming from. And if we see that a large population of users are coming to the cloud through San Jose peering point, that's a great incentive for us to invest in more front door infrastructure in that very location. So the front door is installed there. The user is being automatically directed to the closest front door, and the latency envelope is now 5 milliseconds. So that's what the user experience would feel like for that user in San Francisco. But that's not it. The cloud will monitor where the user is coming from. And giving the flexibility, if you provision the tenant and define your geographical boundary in their non-heavily constrained way, then many applications will consider moving the data closer to your user. Now, the signal that they're getting is where the user is coming from into the Microsoft network. The example of the application that moves your data around within your defined compliance boundary, so security people, please do not freak out, it's within your compliance boundary. The example of the application is Exchange Online. Your mailbox, in the fullness of time, will try to gravitate to the location closer to the user. Now, how does the cloud know where the user is? Well, it all depends where the user enters the Microsoft network. Now, it's all coming together. Enter the Microsoft network sooner so that you can hit the closest front door so that the cloud knows where you're coming from and move the data over time closer to that location. Now, let's see what happens if the customer says, no, I don't buy any of that. I am the private connectivity company, right? I want all my clouds to be consumed over point-to-point private connection, IPsec tunnels or MPLS VPN, and I pick a location in Washington, D.C., where I want to drop my cable, establish the private peering relationship, and consume Office 365 from there, right? In this case, that user in San Francisco will be gravitated into that private network segment, right? In the end, private network is created to contain the user traffic into a specific path. But the latency envelope will increase. Now in this topology, it's 85 milliseconds. And what is worse, the cloud will detect that the user is now coming into the service through Washington, D.C., and it will move the data, the Exchange mailbox, closer to the data center in Washington, D.C., which means away from the user, right? That is one of the main pitfalls that we see enterprises make when they try to hairpin the traffic into Office 365 through fewer egress locations. That shifts the data in the way where you don't want it to be shifted away from that users. All right? Now, let's take a look at another important concept here, which is, this is all rather complex, all these details. How do I reason on top of that in a simple and actionable manner? And the principle here is actually fairly contained. No matter what the front door technology is, no matter where Microsoft has a peering location in the given region, always try to egress your Office 365 data, those vital few flows that we discussed, those optimized set, as locally and as directly to the user as possible, right? Also, let's be mindful about the DNS name resolution. That is important. We're going to double click on that later, but right now the message I'm trying to sink in your brain is direct and local escape. That's what enables a lot of the performance characteristics when it comes to networking for Office 365. Now, let's take a look at the DNS side. I mentioned that egress the data for optimized set locally and directly, and DNS matters. So let's see why it matters. The reason why DNS matters is because many cloud applications, they use DNS to make the front door proximity selection decision. And if the DNS name resolution egresses away from the user, despite you may be taking full advantage of the Microsoft network backhauling, you may not be hitting the right front door. So let's see what the scenario may look like. So in this example, the user in San Francisco backhauls their DNS requests to the data center in Atlanta, Georgia. This is where the name resolution plane exits the enterprise perimeter. In this case, the cloud will say, well, I used GeoDNS logic to identify the front door, and I will direct the user to the service front door in Atlanta. The user is still backhauling across the Microsoft network, which means that at least partially the investment is accruing, but they're not picking the best front door. Now, let's imagine that the enterprise uses some cloud-based DNS provider that backhauls the requests. They may hand the request to that cloud-based DNS provider in one location, and it pops up in a completely different geo, in which case the user, even when they egress locally, may still select the front door in the remote location. So the best practice here is try to coincide the DNS name resolution egress with their data egress. Again, just for Office 365 optimized set. That's the vital few. You don't have to go hundreds of domains. You just have to solve the problem for 3. 2 for Exchange Online and 1 for SharePoint. and Skype for Business and Teams Media, they do the application front door discovery by means of IP addresses. So 3 changers, 3 destination domains, and your name resolution plane could coincide with the data plane. Very important concept when your users need to connect to the closest front door. So that is the same question. How can I reason on top of that and stay future-proof? The answer is always egress locally and directly for your key Office 365 applications and for the DNS name resolution for those. All right, the world wouldn't be complete if we didn't talk about SSL interception. We get this question all the time. This technology is called SSL break and inspect sometimes, and it is a very popular means to arbitrate the traffic that goes from your user to the external web destination. Conventional web browsing to the internet is often subjected to that scrutiny. It does drive hub and spoke mentality, right? Because in order to intercept SSL, you need to have a device that is placed in some locations, and usually these devices are quite expensive. So that limits the number of locations where you can practically afford keeping them in. And for the internet traffic, it's not that bad because the volumes are not so big and the protocols are simple, right? You take the certificate, you spoof it, you make the client believe that it's the endpoint, you look inside, you can reason on top of the web traffic. You can scrub, you can block, it's simpler. When it comes to Office 365 cloud and any other software as a service cloud, it is getting much more challenging and impactful. So if Office 365 traffic is being hairpinned through the SSL break and inspect logic, either proxy or WAN acceleration or another action like that, then it becomes very challenging for the reasons that Office 365 traffic is not just web. There is tremendous protocol complexity. There is performance and scalability concerns, especially at scale. Some of their cloud scenarios have such complex protocols that many solutions, even if they strip the SSL encryption wrapper, they look inside the protocol and it's like, I cannot reason on top of that. You know, who can understand MAPI in today's days, right? What if MAPI is double encrypted? Voice and video, how can you reason on top of that even if you know that it's voice and video? In this case, blocking application is often the choice that many of these security products opt in if they cannot reason on top of that. And this is exactly what you don't want for your mission-critical Office 365 experiences. Plus, the industry is fighting back. New protocol innovation, double encryption, quick, TLS 1.3, and some of the Office 365 scenarios start using certificate pinning. All of those make SSL interception not just fragile and complex and costly, but also non-interoperable. So our official support position is published here. This details out what we encourage our customers to do and not to do with our Office 365 network flows when it comes to SSL interception. But I think the key point here, to make it on the positive side, is we encourage our customers to evolve their security strategies away from traditional network-centric approach and start using more Office 365 native features, which you already paid for, to accomplish the same outcomes. Now, a few years ago, we had strong feedback from customers to say, well, I evaluated Office 365 features. They still don't deliver the outcome that I need, that my security team needs, to give up SSL interception for Office 365 traffic. We said, well, we would be curious about your feedback. And number one reason was, I trust my own tenant in Office 365, but I don't want my users to connect to their personal tenants, right, or to consumer tenants. That's what I want the security assurance against in my hands, right? And we said, great, let us develop a feature. And we created a feature to address that specific risk. It's called tenant restrictions. You can look it up, offline. But then the customer says, well, I need better DLP in order to give up, SSL break and inspect. I need better compliance posture. I need better monitoring. And We are continuously investing in that area to give customers more and more reasons to shift the focus from purely being network-centric, which doesn't quite scale for the reason here, to be a combination of both network and the application, right? So very, very important point. Now, let's do a show of hands just to level set where you are in this overall network connectivity journey here. How many of you are in the local egress from some branch offices with matching DNS name resolution, or you have some tangible plans to get into that state? Anybody? Maybe 10 people, right? How many of you are thinking or doing local egress, but completely were not aware about the importance of the DNS? So your DNS still goes somewhere else. Okay, maybe another 10 people. How many of you are still using that remote data center or remote cloud security provider to egress your Office 365 traffic? Now, I'm not talking about the internet, just Office 365. How many of you are in state number 3? You long haul across the private network and then you egress it somewhere in the remote location. Well, maybe another 10 people. How many of you are fans of private connectivity and will never give it up even if your Office 365 is not performing? Well, I'm glad to report that there are no hands. And then I think the vast majority of you who didn't raise any hands fall into category number 5. Or close to that, where you didn't realize that this is important, but now you will go back to your network and security teams and raise the point. All right, now it's time for the second part of the demo, right? Same Contoso customer, but now we're going to try to enable the direct and local escape. And the way we're going to do that is we're going to go back to the same workstation. It's left in the same state. So I'm pinging my Office 365 endpoint using TCP level ping. So this time it's SharePoint. So I'm still 200-something milliseconds away. And then I'm using the web services call to that newly announced API. I'm downloading the optimized set for Office 365. And I'm going to try to influence that device with a script, right? I'm going to try to enable that flow. So hopefully that device will work out. We're going to see the latency envelope starting ticking. It's 11 milliseconds now. So I'll round it up to 12. It's still on the several orders of magnitude better for the same user than it was before. Now, pinging the regular internet, yahoo.com, is still far, far away. It still follows the red path. So I didn't change my internet relationship. I just locally egressed Office 365 key traffic. So let's see what the user experience is. I'm going to SharePoint. I'm downloading the same file. And I renamed the file in this demo so that it's not pre-cached. And it's about 6 seconds to download. I recorded 7, just if there are any doubters. I actually finished the file download. Last time I had to bail out because I was running out of time. My next step is I'm going to go and start Skype for Business network assessment because it will take 17 seconds to complete, and I want it to run in the background. So I'm using the same very tool from the same very device, and while it's running, I'm going to go back to Outlook and try search for the same keyword, SharePoint. And I'm going to record how long it took, and it took 118 milliseconds, which is more than twice better than it was before. And then I'm going and simulate my delegate access scenario. Delegate calendar online mode in Outlook. Double click, no donuts, no freeze in the UI. I can call it delightful. We can argue about that after the session, but still on the order of magnitude better. And then Skype for Business network assessment comes back with numbers that are well within the Microsoft recommended guidelines, right? So in this run, they will pass the network assessment in flying colors. Just one script, one device, one action, local direct egress, order of magnitude difference to the end user experience. So now my user in Sydney is happy, right? Let's try to put it all together in the reference architecture slide. I'm going to accelerate a little bit because I want to leave a few minutes for questions. We discussed the taxonomy for Office 365. Optimize, allow, and default gives you a priority treatment. So we'll start with a branch office in Portland as an example. The first thing that we need is the CPE device that can tell Office 365 from non-Office 365 device. Office 365 got even bigger as we were discussing here, so now it occupies half of your screen. You can choose 1 or 2 ISPs locally, depending on your availability needs. Some of their local CPE devices can reason on the service quality that different ISPs provide. It can fail over. It's a very powerful concept. These ISPs have multiple peering points, so that's your full mesh type of mindset. DNS name resolution, you egress these vital few optimized sets locally through conditional forwarding, or some of these CPE devices, they can't do it natively for you. And then the cloud will gravitate the data to the location, to the data center closer to the user, in this case, Quincy, Washington. You're getting maybe 300-mile type of experience to the data. The front doors are even closer. Front doors are distributed, so you are guaranteed in this case to hit the closest front door with the right data egress and name resolution egress. You focus that action just on the optimized set, just on these 3 URLs and Skype for Business and Teams Media. So very focused set. Your security and network people do not have to catch their head on fire. You're not changing the internet relationship. You're focused on just these vital few flows. You may add the allow set, which is the next set of URLs to make the experience even better. And then your default still goes to your original data center. So no changes. So that is putting it all together in one big thing. Now, we accomplished a very important paradigm shift here. We effectively extended the security perimeter of your enterprise into the concept of the Office 365 tenant, which is now going back to the point of re-envisioning the security boundary. You already place your data inside Office 365 tenant. Why not make it as a part of your security boundary that you can control and leverage Office 365 features to do that, not network? Now, I have to mention the word about SD-WAN, right? And the biggest attraction that we have for SD-WAN is the letter S, software. It gives the power of software to the network to reason on top of the application flows, and it allows you to accomplish many of the principles that we discussed here natively within the platform with the right SD-WAN solution. Many SD-WAN solutions, they have application-level intelligence, but they don't necessarily align with these principles. They decide to backhaul Office 365 traffic, right? Or they may decide to subject it to SSL decryption. So the key method here is to evaluate the SD-WAN solutions for Office 365 principal alignment, and then they are your best bet to accomplish that direct and local egress where the user is in the branch with an SD-WAN device, can start having a great Office 365 experience, while the rest of the traffic can continue to go through your original security stack. So you don't have to change your security relationship with the internet on day 0. Now, the state 1 and 2 here represent a value add that their SD-WAN devices can provide, where they can have highly available connectivity experience over commodity, low availability ISP ecosystem. They can intelligently fail over key flows and basically save the day. You don't have to have gold-plated network in order to have a highly available Office 365 experience. So the letter S in SD-WAN has a lot of power. Let's plan to put it to good use. Now, we wanted to distill it to the essence, to this vital few things that can serve as the guiding principles for our customers as discussion points within network and security teams. And that's how we founded this slide. We introduced it about a year ago. Words may have been adjusted a little bit to be more clear, but this is the guiding set of principles for Office 365 connectivity. Recognize Office 365 flows, enable local egress, minimize network latency. We saw the profound impact of that by avoiding hairpinning. And then finally, modernize your security. It's less about pure network. It's more about the combination of network and application features. Now, there are a lot of people in this room who like to do it yourself. Maybe you say, I want to go back and I want to try it myself. I'm going to implement some of that. But Microsoft often relies on its partners to help customers automate that experience and deliver native solutions. So we're happy to announce an Office 365 networking partner program where we reach out to the main industry players who provide connectivity and security services, and we try to explain to them the importance of these principles. We give targeted engineering advice on how to accomplish those principles in design, in configuration, and what is more important, in their guidance to you, so that you can rest assured if you use one of these solutions, then you have a high likelihood of achieving those principles semi-automatically. We recently announced that program. There is a link here. And we have a number of partners who are actively participating. Nobody's fully complete yet, but we did want to give you a sneak preview on who are the partners that we're currently actively collaborating. And those are these wonderful companies that are focused on connectivity solutions. Many of them are SD-WAN vendors, so all the SD-WAN goodness that we talked about may accrue through these solutions. If you don't see a partner on the list that you have your existing network based on, we encourage you to talk to the partner and have them reach out to us on the previous link. We'll be happy to provide them guidance, collaborate with them, evaluate their solutions, and drive towards the goal of excellent Office 365 connectivity. Now, I'm almost out of time. I have 1 minute left. Key takeaways. And even this slide has a diagram. I squeezed it in. So 5 key takeaways. Number 1, SaaS is disrupting network connectivity. So there is no doubt about this. Embrace that change. Re-envision how you connect to the cloud and how you protect your enterprise. Figure out the place of your tenant in that end-to-end networking engagement. Number 2, it's all about user experience. The success of the enterprise with SaaS rests on the state-of-the-art user experience. If they don't get the user experience that they want, if their experience is sluggish, or they see donut half of the time, enterprises are not going to be successful in adopting Office 365 and any SaaS service. Number 3, SaaS will evolve and will try to move closer to the user. Every day it tries to get closer and closer to the users out there. Embrace that, enable the cloud to do so, which means that minimize the private network backhaul, because we cannot see through the private network. We cannot get into your private network. And number 4, we created those connectivity principles. Please put them to use. Use them as considerations for your network strategy to keep it optimal and future-proof. And I promise that there will be 5 takeaways. So the 5th takeaway is the most important. Please send this presentation to your network and security team, because in the end, those are the 2 key teams that we've seen over and over again who hold the keys to the most delightful Office 365 experience for your company. With that, I want to thank you and open it up for maybe a couple of questions.